this is for your assignment on VSEPR. Hopefully you've had an opportunity to go through your notes and read up on what it all means. If it was difficult to understand, I promise you that this will kind of bring it all together. So VSEPR is valence shell electron repulsion. And all it is that it's guiding you to knowing what the shape, the geometrical shape is for that molecule, which it's very doable. So let's go ahead and get started. And I'm actually going to help you out with the first two. Okay, so we're going to do number one, which is carbon dioxide. Okay, so if I were to, this time it's a little differently because now it's not having you guess what it is. It's flat out telling you there's one carbon and two oxygens. Okay, so if I know that information, I know since I have one carbon, that's going to be my central atom. It's the one that I have the least of. So I'm going to put it here in the middle. And I also know that carbon is made up of 4 valence electrons. 1, 2, 3, 4. Oxygen is in group 16, so it has 6 valence electrons. So 1, 2, 3, 4, 5, and 6. And I'm going to put another oxygen right here. 1, 2, 3, 4, 5, and 6. Okay, so now I'm going to start sharing electrons. So they can share here, and this one can share right here. I also have some that are available here, so that can be shared, and then this can be shared. And if you recall, we've done this more than once, so that should not be new to you. Okay, so when I rewrite it to make it look pretty, it's carbon. Notice that there is this right here, that bond, and then there's this bond. So that's a double bond. So it's like this, the O. Here's another double bond on the left. And I just can't forget to put the lone pairs. So 2 on the top, 2 on the side. I'll do the same thing to make it look symmetrical. Okay, so that's what it looks like. Once we have that done, that's when we can start answering the questions. So the question is asking how many atoms are attached to the central atom. Okay, well, let's look. We have this one attached to the central atom, and the central atom is the one in the middle. And this one's attached. So we have 2 atoms attached to the central atom. Okay, so we're going to go ahead and write that there are 2. The next question is asking how many lone pairs, not on the side atoms, but on the central. And if you notice, there's no lone pairs. It bonded with those atoms. So therefore, the answer is none because there's none on it. Okay, so we would put 0. So now using this information, we come up here and we look for the information here. We need to see a 2 for bonding directions and a 0 for lone pairs. So 2 is 0, what we would be looking for as first. Okay, so the type or the geometry name here is linear. So it's a linear type of geometry. And this is a shape it would take. It would just be straight. Okay, which we already have it like that. So if we come over here, we would go ahead and put down, and I'm just going to type it, linear. And there's no other name to it. It's just a linear. Like you see here would be trigonal planar, and it could be bent, or tetrahedral, and it could be trigonal pyramidal. But here it's just tetrahedral, or linear, I'm sorry. Okay, so now we defined it as linear. We went ahead and put it down. Now the Lewis structure, we already have it drawn. So we're going to go ahead and draw it into this space right here. Okay, so let's see if I can do this without messing it up. We've got the O, and then the double bond. We got the C, the double bond, the O. Okay, it's not looking too bad. And then, hey, it actually looks pretty decent. Okay, all right. So then the next one is, oops, go ahead. Is to draw the shape. Okay, so to draw the shape, we're going to take a look at, well, what does the shape look like? Okay, so for the shape here, linear is just a line. So that makes it pretty easy. We know that it's actually going to be the same thing, but we don't need to put the lone pairs. So it would just be, actually going to do it in another color. O, double bond, C, double bond, O, and that's it. And then it's asking for the bond angle, which is up here. And you guys know that the struggle is real whenever you're trying to get PowerPoint to maximize and do all that. But it says, what is a bond angle? So no need to worry. If you look, approximate bond angle, 180. And that's what you need to put. So 180. There we go. Okay, so that's the first one, right? Let's look at the second one, which is H2O. Okay, so for H2O, you know, we have 2 hydrogens, 1 oxygen. Okay, I'm going to draw the oxygen in the middle because that's the one that has the least. Also, it happens to be the least electronegative, so it has 6. 1, 2, 3, 4, 5, and 6 valence electrons. Then you have hydrogen with 1, and that one's going to share right here. And then we have another hydrogen, which is just 1, and that shares right there. So if you remember the step on making it look pretty, it's going to be a hydrogen, then the bond to substitute the bubble, the O, the other bond, the other H, and it has 2 lone pairs. So I'm going to put 1 pair here and 1 pair here. So now we can actually answer the questions on the chart. So how many atoms are attached to the central atom? Okay, easy. Here's a central atom, it's O, and 2 atoms are attached to it. So that means we're going to put 2. Lone pairs on the central atom. Well, are there lone pairs? Yeah. There's 1 pair and there's a second pair. So there's 2 lone pairs. So easy enough, we'll put 2. What is a geometry name? Well, let's take a look at our chart. So if we have 2 and 2, which is right there, it says that it's a tetrahedral and it's bent. Okay, so tetrahedral and bent. So that's what you're going to put down over here. Whoops. And I'm going to type it out. Tetrahedral. And we'll indicate that it is bent. Right. So now the next thing is to draw the little structure. So what we had here, we're going to go ahead and draw it in the little box as best we can. Okay, so it's going to be, remember, the H, the line, the O, the H, and lone pair right there. Okay, so now it says draw the shape. All right, that one, you may have to look it up. And if you look at the shape, it's a bent and it looks just like this. I'm going to circle it. All right, so we want it to look like that. We can do that. Okay, so let me go ahead and just draw it on the side, a little sketch of it. So here's my central atom. Here's another line, and it had the lone pairs like this. Okay, so we need to make that look like this. Okay, so easy enough. Here's the O. Here's the bonds. The H's are at the end. And the lone pairs. 1 pair here and 1 pair here. And so that is what we would draw. H, O, H, pair there. Okay, and then the bond angle. Easy enough, we just look it up. The bond angle is 109.5. So just 109.